ZetaChain is an EVM-compatible L1 focused on interoperability. Uh, what this means is you can deploy a contract on ZetaChain, so any EVM contract, and it will be automatically callable from any chain connected to ZetaChain. So what this means is, let's take a look at an example. We have a contract on ZetaChain. We call them universal apps because they are universally accessible. And we have Ethereum, and a user on Ethereum can send ETH or any other supported token and the message to this contract on ZetaChain through what we call a gateway contract. So this makes it possible for any user or any contract on Ethereum to interact with your contract on ZetaChain very easily. And in addition to Ethereum, we have chains like BNB, Polygon, Base, Bitcoin, Solana, and soon Sui, and other chains in the future. We actually have Avalanche and Arbitrum as well. Forgot about them. But all of these chains are connected to ZetaChain, and users and contracts on these chains can interact with your universal apps. But what's even more interesting is that your universal app can actually trigger token transfers from ZetaChain to connected chains. So let's take this cross-chain swap example. We have Ethereum, a user on Ethereum wants to swap some native ETH for BNB. So they interact with a gateway contract on Ethereum, which calls a universal app on ZetaChain. Uh, ETH is represented on ZetaChain as ZRC20 ETH. ZRC is basically an ERC20 with some additional features. You can think of it as an ERC20 token. And the contract executes swap logic, which then results in a withdrawn call execution on the gateway. So ZRC20 ETH was swapped for ZRC20 BNB, and it was withdrawn to the BNB chain through the gateway. And a recipient or a contract uh, will actually get native BNB. So ZetaChain is focusing primarily on native assets rather than wrapped assets. So every time you withdraw, the receiver on the connected chain gets native asset, be it BNB or USDT or any other supported token. So this makes it very easy to build applications that are cross-chain by default. So you can implement a cross-chain swap in like 100 lines of code, and it will be compatible with all the connected chains. And the cool thing about it is that the whole code of the whole source code of this app is actually on ZetaChain. So you don't have to set up contracts on all these connected chains. Users just interact with the ZetaChain gateway to call your contract. And of course, this is not limited to just swaps, right? You can execute any kind of logic. So the way it works under the hood is ZetaChain validators actually observe all these connected chains like Ethereum and BNB, and whenever they notice an incoming transaction, they vote on it on ZetaChain. So it's a decentralized system powered by TSS MPC. So every incoming transaction is processed by a network of observer signer validators, and the same goes for outgoing transactions from ZetaChain to connected chains. Validators see that a call is being made to ZetaChain gateway, and then they go through a signing ceremony to make a transaction on a connected chain. For example, transfer BNB from validator custody to the receiver. So on all chains, these observer signer validators actually have custody of tokens. So whenever a user or contract sends tokens, they're actually stored on this chain, just locked in validator custody and unlocked um, whenever they're withdrawn. So I propose we go directly into the code and look this is how this works and how we can build universal apps. It's actually very, very straightforward. So let's jump in directly into the code. So what I suggest you do is clone um, zeta-chain example contracts. Um, and this repo has all the examples that you need. I already have it cloned, but check it out here. So let's open up the repo. So in the examples directory, we have a few examples. Let's start with the simplest one, the hello world. So it's just 30 lines of code. Pretty much that's all you need to get a universal app going on ZetaChain. Is just a single Solidity contract with a function on call. And this function gets called whenever a user or a contract on a connected chain like Ethereum wants to call your contract. So a call from Ethereum, a call from Bitcoin, Solana, they all end up here. And this on-call function is executed in your contract. Um, the logic is very straightforward. We just decode the message. It expects to see a string, and it emits an event. The context contains information like chain ID, sender address, um, and um, and the ZRC20 is the token that is being deposited. So every supported token like ETH, USDC on Ethereum, USDT on BNB, Sol, BTC, they all have ZRC20 equivalents. So whenever someone makes a call from Bitcoin to your contract, um, the contract gets ZRC20 BTC, the same amount that was deposited. And the amount is just the amount of tokens. A message is an arbitrary data passed to your contract. So you might ask, how does this work on Bitcoin, for example, which doesn't really have smart contract capabilities? Well, on Bitcoin, we support OP return. So the first 20 bytes of OP return is the contract you want to call, and the rest 60 bytes is the message. OP return is limited to 80 bytes, but we also support inscriptions for data transfer and calls. So you can use either. On Ethereum, that's a gateway contract call. So you call EVM gateway to make a cross-chain call to a ZetaChain universal app. Every chain, including ZetaChain, has this gateway contract that basically is your single point of entry. Here we just set it so that we can check that the caller is the gateway to ensure that there is no spoofing going on. So you can trust the data that was passed in the on-call, for example, amount and everything else. So yeah, by the way, if you have any questions, just let me know. And but yeah, it should be pretty straightforward. There's just one function, and that's it. So to test this, we actually have a very convenient tool called LocalNet. And LocalNet is basically an environment running on your machine that spins up ZetaChain, a few EVM chains, Solana, and sets up all the gateway contracts to make sure that you have a full environment where you can experiment and actually run these contracts. And it's much faster than testnet. You don't need testnet tokens. You can just run localnet, and um, it takes about 10 seconds to set everything up. But we have EVM chain. You can see call it Ethereum, but it's just generic EVM chain, BNB and Zeta chain. And you can see all the contracts deployed, all the zero-C20 tokens. So all the contracts you need are right here. Ethereum, BNB, and Zeta chain are actually running on a single Foundry Anvil instance, which just makes it a bit more convenient, but you'll still be able to simulate all the transactions. Solana is running on the Solana local validator, and we also have SUI support. Cool. So yeah, it's super easy to get it going, but I don't want to run all these commands manually to test. We have every example has a localnet script file which starts localnet and just executes commands. So here we're just making a call from Ethereum through the Ethereum gateway to Zeta chain, and we're passing a single string Alice. We're not depositing any tokens, we're just making a call from Ethereum to your contract, and let's see how that works. So just run script localnet start. It will again start the same localnet. Every time it starts fresh, so very convenient for experimentation. Okay, so localnet has been set up, and yeah, we can see what's going on here. So we deployed the script deployed a contract on Zeta chain, the same contract that we saw earlier, and it executed EVM call. You can see that gateway emitted a cold event, and on Zeta chain, a universal contract was executed with this context and message amount is 0. Even though we didn't deposit anything, the zero-C20 actually corresponds to the zero-C20 ETH, so it can be used to identify a chain from which the call is made, but of course you can also use context chain ID. And we see that this transaction was executed and an event was emitted from on call. So we can localnet has been killed, but you can make some changes, run it again, and it's very, very convenient to test things out. So I think that's pretty straightforward, just making a call from one chain, in this case Ethereum, to a contract on Zeta chain. Let's look at something a bit more interesting. I have a call example, which actually has two contracts. One is called Universal, it's deployed on Zeta chain, and one connected. You don't have to deploy contracts on connected chains, but you can. Sometimes it's useful because you might want to check that a user has a specific NFT, for example, for them to be permitted to make a call. I don't know, maybe that's the logic of your application, or you want to do something on that chain before making a gateway call. Up to you. You can do that. And this example just shows all the different functions that you can execute. All these functions basically wrap um, uh, the gateway functions like call, deposit, deposit, ERC20 asset, deposit and call, and this contract on a connected chain also has an on-call function because you can make calls from connected chains to Zeta chain. We call these calls incoming because they go to Zeta chain, but you can also make outgoing calls from Zeta chain to connected chains. The reason why we use this terminology is because we think of Zeta chain as the hub where connected chains are kind of around it, and everything that goes into the hub, it's incoming. Everything going out of the hub is outgoing. And a universal contract has similar functions, except instead of deposit, we have withdraw. So when you send tokens from a chain like Ethereum to Zeta Chain, it's depositing. When you're sending tokens from Zeta Chain to Ethereum, it's withdrawing. And you also have withdraw and call. So a lot of functionality built in. Let's run localnet again, just so that we can see all these functions in action. So it will deploy both a universal contract and a connected contract. And now it's going to just make a bunch of calls. So we see that this is just a deposit. So a regular deposit does not call a contract on Zeta Chain. It's just token transfer. You can think of it as bridging from one chain to Zeta Chain. And you can see the asset that was transferred. In this case, that's ZRC20 ETH. Now we're transferring an ERC20 token. So that's probably, yeah, ZRC20 USDC. Let's move on. What else we have? Regular call. We saw that in the previous example. Now we have deposit and call, which is a bit more interesting because not only we're depositing, we're also calling contract. Arguably, this is the most useful function because uh, there, most often than not, you want to call a universal app on Zeta Chain and transfer some tokens to it at the same time. That's what deposit and call allows you to do. So we see event emitted and so on, right? So a bunch of functions just kind of, let's see outgoing calls from Zeta Chain. So here we have universal withdrawn call. So we're withdrawing a ZRC20 assets that's ETH and calling a hello function on Ethereum. So we're making an outgoing call from Zeta Chain from a universal app to a contract, this one, on Ethereum, and calling the hello function. You can see that the gateway emits an event on Zeta Chain, and a contract on Ethereum is called with a message, and we see an event. So it's basically from universal into the connected contract. So a lot of ways to interact between connected chains. Of course, we're using Ethereum as an example, but you can use any chain. The API on connected chains, of course, could differ because Solana has a completely different gateway, but the high-level functionality is similar. You have deposit and call, and the great thing is that the contract on Zeta Chain doesn't really change much, right, or at all. So the same contract that you have already deployed on Zeta Chain that works with Ethereum is just going to work with Avalanche and Arbitrum without you having to do anything or upgrade it, do anything. So this is very cool because the same contract is kind of future proof, right? And um, makes it very easy to build these sort of applications that span any number of chains, be it EVM or non-EVM. So yeah, all of these function calls are kind of similar, but let's move on and check out something even more interesting. So we covered calls. I think it's pretty clear at this point you can make cross-chain contract calls with or without assets. But let's take a look at the swap example. This is a fully fledged application that does cross-chain swaps. It's a single contract again, deployed on Zeta Chain that has an on-call function, so very similar, but now it has some logic. And what it does is basically it decodes a message based on which chain it's coming from. Um, most chains just are going to use API encoding, so this else statement will be used where it just making separate processing logic implementing this for Bitcoin because in OP return at least we're very limited, so we can't use API encoding. But other than that, the logic is exactly the same. We're handling gas and swapping tokens and withdrawing. So this kind of brings us to the question of gas and how this all works under the hood. It's actually very simple. All incoming calls from connected chains to Zeta chain uh, are free, so there are no additional charges, which makes Zeta chain a very convenient kind of uh, gasless execution environment, so to speak. There are some exceptions, like Bitcoin requires a small deposit fee because of the internal working of UTXO model, but from EVM chains, there are no additional charges. When you're making a call from Ethereum to Zeta chain, you're just paying Ethereum gas fees, and that's it. But when you're making a withdrawal, that actually creates a transaction on a connected chain. So when you're making a withdrawal from Zeta chain to Ethereum, observer signer validators will actually create a transaction for you on Ethereum. And for that, you need to compensate the protocol. Um, and you do that inside your Universal app. So before you make a withdrawal, you actually query the token that you're withdrawing, how much it's going to cost you. So you execute withdrawal gas fee, and it returns the gas asset and the gas fee. So if you're withdrawing USDC to Ethereum, it would actually return zRC20 ETH because ETH is the gas asset of Ethereum, and the amount of zRC20 ETH that you need to um, provide to the gateway. So in this example, we're actually taking the incoming token, let's say it's BNB, and we're swapping a fraction of it to cover gas costs, and we're swapping the rest into the target token. So if the target token is USDC on Ethereum, we're taking a fraction of BNB, swapping it for zRC20 ETH to cover gas fees, and we're swapping the rest for zRC20 USDC. The next step is withdrawing. Um, we already have zRC20 ETH for gas. We approved the gateway to use these tokens, so here we do that. And we approve the gateway to use the target token. And that's it. The gateway just burns, well, not the gateway directly, but the protocol burns zRC20 ETH on Zeta chain and withdraws the target token. The reason why zRC20 ETH is burned is because when the withdrawal succeeds, the TSS account owned by Zeta chain validators will spend the same amount that you provisioned for the gas fee. So, and we want to make sure that the balance of tokens in a TSS address matches the amount of zRC20 assets in circulation. So this balance must be preserved, and that's why zRC20 assets are burned, because the gas fee will be spent in the same token on a connected chain. So here we're just executing gateway withdrawal, and that's it. Let's execute this and actually see how it works. So again, we're going to the swap example and run localnet. So in this localnet script, we have a bunch of commands that do the swapping, and we're gonna see how they work. Okay, so the first one is um, we're swapping from Ethereum to Zeta Chain, and the target token is actually Zeta. So you can see that the target token address matches the one that we have for Zeta, and we're not withdrawing. So what happens is we're just swapping ETH from Ethereum to Zeta on Zeta Chain, and it emitted an event because it was successful, but it didn't produce a withdrawal. So you can also do that. It's pretty cool. The next is we're swapping for let's see what this token is. That's USDC on the BNB chain. Let's see how that works. Right. So from Ethereum, gateway is called, universal contract on Zeta chain is called. Then the contract emits a withdrawn event and transferred this amount of USDC on BNB chain from custody to the target address. So we've just made a cross-chain swap of native ETH from Ethereum through Zeta chain to USDC on the BNB chain. Next, we're actually using a companion swap, which is just an example of how you can use a contract to interact with your swap. It's completely optional, just an example of how you can do that. But here, what we actually are doing, the target token is SOL on Solidity. So we're swapping tokens from Ethereum into SOL. And here we see that on Solana, the gateway program was executed and sent some SOL to recipient. And that's actually why the recipient address is in bytes here, because here you go. Yeah, the the to address is actually bytes because the recipient can be on a non-EVM chain like Solana or Bitcoin, and that's why we want to make sure that it's possible to send tokens to non-EVM addresses. And here we're actually using uh, a function to swap from Solana to probably Ethereum. So here we go. Gateway on Solana was called, again, event, and some native gas ETH was transferred to receiver. So very, very convenient way to kind of see how this works. We're just continue swapping stuff back and forth. Um, and yeah, you can take this in if you're building something like a DEX, you can take this as an example and start experimenting with it. When you're done, just run localnet again, and it's just going to go through all the tests. You can think of it as an integration test of sorts. Um, cool. So this is how you can do cross-chain swaps on Zeta Chain. Very easy, just one contract connected to all the chains. Let's take a look at one more example. We have NFTs. So this is cool because this, well, doesn't have much here. It's just basically importing a contract. But what this does is it actually uses the features of the protocol to build something on top of it, which is a universal NFT. So let's go into the docs and let's take a look at the examples. So a universal NFT is basically an NFT contract you can deploy on any EVM chain and Zeta chain, and users can mint NFTs and transfer it to any other chain. So you can deploy this contract on Ethereum, BNB, Base, Zeta chain, and users can mint NFTs on these chains and transfer them very easily. And the way it works is, let me open it a bit bigger. So it also uses the same functionality that you're already familiar with, deposit and call. and withdraw and call. So in this example, Alice mints NFTs on Ethereum, then she uses transfer cross-chain function, which in turn uses deposit and call to the gateway, sends a message to Zeta Chain. The NFT contract on Zeta Chain, even though it acts as a regular NFT contract, it also routes calls between all the connected chains. So when you're sending an NFT from Ethereum to BNB, it actually goes through Zeta Chain first, which is very convenient because you have a single place in this whole system where this routing takes place. So you don't need to think about how an NFT is transferred from Ethereum to Arbitrum, for example. It just goes through Zeta Chain, and it's just withdrawn call to transfer it to a connected chain, in this case BNB. So transfers the call, makes a call to this NFT contract, which mints an NFT to a receiver. And for these transfers, you're actually using native gas assets of connected chains. So if you're sending an NFT from Ethereum to BNB, you're paying native ETH. And this is very convenient because you don't need to think about gas asset. It's all taken care of by the contract. And if there is some extra tokens, it will be transferred to Alice. Let's say the price has changed because this takes some time for this transaction to be processed. So if there is some extra tokens, then they will be transferred to Alice on the connected chain. But ideally, there are no extra tokens because you queried the contract and supplied the right amount of tokens. So this is very cool because you can just deploy contracts and users can mint NFTs, transfer them around. And of course, you can override these functions. So if you don't want anyone to just be able to mint the tokens, you can disable this functionality. So there's a standard contracts repo, which has the logic for universal NFTs and universal tokens. So you can take a look. Um, Universal NFT Core, which is a pretty small contract uh, that has a function called transfer cross chain, which calls the gateway to send the token. You can either send it to Zeta chain where the destination is 0, or you send it to another chain. You can check it out, but it's fairly straightforward. And on the receiver end, if it's another EVM chain, on call is executed. So yeah, let's go back to the examples and actually run it. And I think it's going to make much more sense. Um, Again, we have local net shell script here and a bit bigger. And so right now, universal NFTs and tokens are EVM only, but we will be expanding this to other chains as well. So for this system to work, you have to deploy these contracts on all the chains you want to connect. So in our case, we're deploying universal NFT on Ethereum, BNB, and Zeta chain. And we'll see how the transfers go. Okay, so the initial state is that there are no NFTs. We're checking balances 0. Right now we are minting an NFT on Zeta chain. There are no cross-chain operations so far, just minted an NFT on Zeta chain. You see that it's 1. And now we're actually using NFT transfer function to send a token with a specific ID to uh, a destination. This is the ZRC20 asset, uh, ZRC20 ETH specifically. So we're sending an NFT from Zeta chain to Ethereum, and Again, on Zeta Chain gateway is called, which prompts the protocol to call Universal NFT on Ethereum with a message, and the Universal NFT contract on Ethereum mints token emits some events. And now when we check the balance, we see that the NFT was transferred. So there are no longer NFTs with this ID on Zeta Chain, but there is one on Ethereum. Now we're sending token from Ethereum to BNB exactly the same way. We're supplying some gas tokens as well. And this is pretty interesting, right? We're making a call on Ethereum to send an NFT. It goes to Zeta Chain. So Universal NFT on Zeta Chain is called because it routes this transaction to the BNB chain. And withdrawn call was emitted. And now the BNB, say on BNB, Universal NFT is called, and it emits events that the minting was successful. Now we have the token on BNB chain. And now you probably guessed it, we're going to transfer it back to Zeta Chain, just so that it makes for a full circle from BNB to Zeta Chain. Gateway was called, and Universal App emits events that the NFT was minted. And here you go. So the NFT returned back to Zeta Chain, and I don't know, I think it's pretty cool. Very easy to deploy, and um, you can take a look at the docs. We have an example of how to, I mean, this is just a simple import statement, but you probably want to start with an OpenZeppelin template instead. And with just like 10 lines of code, you can take a OpenZeppelin ERC-721 template and turn it into a universal NFT. We actually have this on, well, you can test it on testnet, of course, but we also have ThirdWeb. So if you're a fan of ThirdWeb, you just want to experiment with it, you can deploy it from here. The important part to know is that you need to deploy a universal NFT on Zeta Chain. It's a required part of this whole system simply because this contract routes cross-chain transactions. Without this, not going to work. You can disable mint on Zeta Chain if you just want people to be able to transfer NFTs between connected chains, like between Ethereum and Base or Arbitrum, for example. Up to you, really. But yeah, super easy to get started. And of course, we have a universal token, which is very similar to Universal NFT, except it deals with ERC20 tokens. So you can mint a meme coin on Base and let users transfer it to Ethereum or Polygon. Very easy. Cool. So yeah, I think we covered most of the topics. So yeah, let's just do a quick recap. We kind of took look at we looked at a very simple example where you just have a contract that emits an event and call it from any chain. Um, Swap example, cross-chain swap, one contract that accepts calls from connected chains and produces output on other chains. And we took a look at the NFT example where you just deploy a contract on a bunch of chains and let users easily transfer the tokens.